How's it going, everyone? Welcome. Euler Gonzalez here again, and we're gonna focus our attention to this section of the learn topic of how you can manage your state by looking at how can you extract the state logic into a reducer as a way to recap that, and also look at how can you scale up with reducers and context. And what is context at the end of the day, so we can move on to now escape the hatches, or aka looking at how you can synchronize your components with outside systems or systems outside of React. So this is part of the course about the React performance, okay, which is taught by Steve Keeney, head front-end engineer at Temporal, a durable platform, a durable execution platforms, where now you can think of this like a Kubernetes to cover a specific business use case. So for example, companies like Vercel is actually using that, or as a way to now, instead of you having to deploy your applications there, instead of you having to figuring out how you need to deploy your applications in one of those servers, they provide is just a wizard or this onboarding process as a way to just only put the repo, set some flags as a way to what you want to do. You want to build the project, you want to test the project, you want to run some tests, and then the build step. So they now deploy your application, and there is a lot of interesting things going down there. So because the goal of this course is to look at how can we write React component in the most performant ways, and in today's video we're gonna see now a quick recap of this learn section as a way to describe the UI, adding interactivity, managing state, and last but not least is escaping the hatch, as a way to understand how React works. Because eventually, if you're going to actually solve performance issue, you will need to know how that thing works. So then you can build a tool set when those problems come up and provide some sort of solutions or come up with some best practice for that. So this is pretty much like untying a big knot. So when you're pulling the right threads with the technique that you already know over and over and over, this is something interesting because it works not only for small apps but also for bigger apps. So before moving into that, so before moving into that, we'll finally wrap this section here, okay, as a way to understand now, well, what React offered to do, what React is. We're gonna make a quick recap over the entire learn section here as a way to describe how do we get here, and lastly then we can move on to these sections, the escape hatches. And I think that I'm gonna do this over a couple of days as a way to improve my technical communications, and also how can I writing this stuff, which is how to put up practice my writing skills here. So because after all, React is a JavaScript framework, it allows to describe user interface. So we look at how can we do that by using this JavaScript function. How can we import and export React components? How can we now connect JSX, or how can we now connect the JavaScript to our HTML through JSX, conditional rendering, list rendering, and also how important is the key for this, each one of element that you're rendering, as a way to tell React to, hey, this is the state that I want you to keep track of this. And also I want you to now keep track of this element for you. Pretty much like if you have a folder, and if you don't know what if you have a folder and if you don't know the file index or the file's order, so if someone come up and pull out a paper, you don't know what's going on. So the idea here is that notify React to do that. And also how it's important to write our components in a functional way, because first, it allows to run this function in any JavaScript environment, whether it's the browser, the server, or workers, as well as we can safely stop the execution of all of these functions if we need, for example, do that. Let's say you're causing a re-rendering, but another component caused a re-rendering. So it's safely to actually stop the execution and resume that. As well as when it comes to catching, using memoization techniques like Memo as a way to, hey, React, I don't want you to re-render this component. I don't want you to calculate, to evaluate this component. So we also look at the render tree as a way to understand now how React sees these components using the tree data structure, which makes for us, the developers, an understanding of how can we detect performance issue, as well as how the data flow goes through that. Something that we're going to talk about that later, as well as the React, the tree dependency. So far, so good, no problem. So what happened is that once we know how to describe our UI, we need to look at how can we adding interactivity by connecting to our functions, to the event handlers, which is after all is provide some synthetic events from React. So we look at how can we connect that, as well as how can we now show some data to the user. For example, you have a bank. In your bank account, you want to look is your balance and your transaction history, credit card history, that kind of thing. So it is important to actually show some data. The way to do that is by using states, which is a component memory. Behind the scenes is using closure, which is now a feature from JavaScript, a nice little feature. I'm not going to dive too much in that. The whole point is that it allows us to store data here. We also look at how can we set the state as a way to update that, and when we do that, we trigger a rendering mechanism, which is something that React does when we detect is a state update. So it is made of 3 phases. You get the trigger, the rendering, and the commit. And in the trigger is when it detects that, hey, is this happening on at the initial render, or a component or any of its ancestors whose states was updated. Then move to the render phase as a way to now evaluate this. So rendering is just React evaluating the components. So if this is on the root element, what it's going to do is to create all of these elements. So it have now the create React element, which is coming from the document create element. So it's going to create all of those elements. However, if it's part of a re-rendering, you're going to call the component whose states trigger the updates, evaluate all of its properties, event handlers and props, store that data there, and then the output of that component, if that contains React components, then it's going to call those components, and it's do that until there is no more component by going in, dive deep into the render tree. So this process is doing in a recursive way. So recursion is another important concept to actually take a look at that. Okay, so with that, okay, as we look now of the rendering phase, when it comes to the commit phase, React say, hey, let me now apply only the necessary dump updates if this was caused by a re-rendering, meaning if this was caused by a component whose state updates that. And then I'm going to apply is the necessary dump updates. If this was caused at the initial or the root element, what it's going to do is to append all of these elements that it created in the previous step. So now you can see the UI. So if it's not, if it's part of the render, it's going to apply the necessary dump updates as long as they're different between renderings. Therefore, now when the browser detects that, it say, all right, this DOM element is changed, let me repaint this. And this process is something mechanical, it's doing over and over and over and over and over. So understand this is now it's going to lay out the foundation for what's coming next. And that is, how can we now think about our states? And you may wonder, why do I need to look at that? Why do I need to think about in terms of states? Especially when you want to update your state, you want to know what's going on. You know, not only what React is doing as a way to render that element or to paint that element, but how can you work with states? Okay. So how can you work with state in your components? So if you want to mutate the state, you do that inside of an event handlers, and React fix the state value within the event handlers render, okay, or evaluations. You can think of that. And the other is that if you want to have access to the next value, you will get that in the next render. So with that, we also look at how can we now enqueue series of state updates as a way of saying, hi, I would like now to send several orders to React. Hey, take all of these orders, takes all of these orders. And another useful and interesting use case, not that common, is that how you can now work with the previous state while you are in the event handling, as a way to, for example, deal with some async operations in there. For example, set the timeout and that kind of thing. So what's next, okay, is that how can you now update objects and array in a state, always return a new state. The TLDR of this, or the reason of why we do that, is because there is something called solid. If you come from object-oriented programming, you know how hard it is to actually mutate the state of a component. And not only that, if you do that, there cause rippling effects through your entire app. So the solid is a way of how now developers can write this kind of applications without receiving a call at 1 a.m. without receiving a call at Saturday 1 a.m. No, right? Hey, something went wrong. Got French toast. We don't want that. And then after we look at how can we now add interactivity to this, when it comes to now describing our UI components or reacting to input states as a way to managing the state here. So the way how we react input with states is just as a way of how now the mental model of React promote and give us to say, let's go to write this component pretty much like the UI designer does when they describe is their wireframes, okay? And following is a descriptive descriptive approach, being descriptive about it. So you can also have some imperative approach. We're not going to discuss about that. The subtle difference between imperative and declarative is that imperative allow us is to have much more fine control of what's going on. The trade-off of that is now you will have to write that code over and over and over, and not only that, when it comes to actually manage and scale that kind of application, it becomes quite cumbersome to do that. So yeah, with that, all right, we look at what is the mental model that React give us as a way to react to input with states, and that is pretty much combining is the UI design, where you visualize all of the different states with the computer science concept of state machines. Yep. Oh, state machines. Or finite state machines, which is a way of how you can describe the different state in an application. In other words, you can describe as if you are a, you can describe, okay, you can describe now the different state that your cell phone can be, which is turn off, turn on, yeah, like turn off, turn on, the lock screen, and so on and so forth, right? You're not able to actually describe all of this and how all of these transitions which is happen, and how all of these transitions happen from turn off to from turn off and turn on to the lock screen, like this. Okay, I almost actually accidentally show my screen. And that is, well, the way of how the UI designer actually do this work. We are combining with this finite state machine as a way to now React say, hey, when you are going to react to input with states, first, visualize all the different visual states. Second, identify what trigger those state updates, whether it's human or computer. Okay, I like to prefer to do this. So identify all the different visual states, then determine what trigger those state updates, whether it's computer or human. And by computer is, well, responding to some data from the server, loading image, timing out functions, and for user input or human input is like, hey, typing or clicking, or yeah, typing or clicking or navigating to a link, you know. So this is something that lay out the foundation, okay, to now represent those states with use states, and then avoiding non-essentials so you can connect your handlers to set the state. And this is a process that is going to do that over and over and over, especially when you're going to describe your components. And I'm going to do that when define is when I'm going to define is the Trello board. I'm definitely going to that. But in any case, so yes, yeah. Okay. Okay. Yeah. Okay, so because of that, then we look at now how can we organize our state. This is also the following is a concept from the database engineer called normalization, which is eliminate redundancy and duplication. So the way or the principle now React tells us when we're writing a component or when defining our state or organize our state is, well, group related state together, avoid any contradictory states, avoid any redundant states. Ask yourself, can I get this data from this prop or from another state? Avoid duplicate state because that will cause it will make it hard to keep in sync. All right, and avoid object deeply nested in your states. So that will lead us now of how can we share state across multiple components by lifting the state up. And this is a process that is fairly common that you're gonna do, okay? Not only for filtering elements, but also for tabs, for example. So when you do this, and each piece of state, each piece of state, you will choose which component owns it. Okay, so owns it. And by that is that component will become the source of truth of all of these nested children, all of these children. So the idea behind this is by understanding this particular concept of sharing a state between components as a source of truth, and also how now can we describe in terms of how to design this component and what its capability offer is in terms of uncontrolled and control form. And this is just to say, hey, is this component it'll be driven by these props, something that they mention here, and I think that's quite interesting. Preserving and sharing between here as a single, no, this is what they describe here. So hey, when writing this component, consider which information should be controlled via props or which information should be uncontrolled via state, as a way to design, as a way to create this component. Which information should be a state uncontrolled, which information should be a props control. You can always change your mind and refactor that later, because this is part of the process. This is part of the process, and this is also part of the thinking in React, especially when you are describing is this, right? Start with a mockup, break up the UI into a components hierarchy, like so. Programming, CSS, and design. For example, this. Filterable product table. Only show product in the stocks, which is the search bar. And then you got the product table with the product category and the product row. A pretty straightforward application like this. Okay, but doesn't have any interactivity. Exactly. This technique that you're going to learn in the tutorial, fundamentals to build any React app, and fully understand, it will give you a deep understanding of React. Lifting state up, showing the past move, picking a key, implementing time travel. Again, but this is a very simple game here to implement that. As a way to implement is this. And it's evaluating this. Implementing time traveling. So anyway, the idea here is that we're not going to actually do this, you know. It's like, no. Yeah, it's like, no. We're actually not going to do this. In fact, we just is to describe what's going on after the, yeah, we're going to describe what's going on after the managing sharing state across different components, and how you can think in terms of React. So next is then how now to look at the state, okay, when managing your state, and the state is tied to the position. So the state is tied to the position in the render tree, which means that if you have the same components at the same position, React will preserve that state. However, if you have different components rendering in the same render tree position, React will reset the state. If you want, for example, reset the state of the same components that are in the same position, or you render that component in another position of the tree, or you use a key as a way to say, hey, this component that I want you to render, I want you to keep track and mark that like unique here. Okay, so anytime you now tie the state to this component, that's exactly what you're gonna do. So you're gonna tie this component to this particular state and reset that with this. And I think that's quite interesting, because that leads us to the next topic. And the next topic is, well, how can we now, for example, when dealing with more inputs, so the more an state has to deal with several inputs, whether it's computer or humans, the more likely is that you use reducer as a way to extract the state update logic into a reducer. So I look at how can we do that. So if you want to replace that state with the use reducer, you look at those states that are changing. You look at those state change when you look at those setters, those state setters inside of your event handlers, Jesus fucking, sorry. You look at those states handler, you look at those state setters inside of the event handlers, you replace that with dispatch, and you're gonna pass now an object called action, which contains the type followed by the user interaction that you want to perform and the data that you want to change or you want to update. Here that you define is your reducer function that takes in the state and an action, and then you now return is a new actions based on the actions. You can also do that for your state. Okay, and as you do this, it becomes increasingly more interesting. Okay, it'll become increasingly more interesting. Yeah, it'll become increasingly more interesting. It'll become increasingly more interesting here when you need to now handle is all of these different user inputs, of all of these inputs in your state as a way to return is a new action for that. And then in the component, you use now the reducer, with the first parameter is the reducer and the second parameter is the initial state. And I look at how can we now, with using these selection UI patterns, for example, like using an index and that kind of thing, how interesting is to now reset the state of a chat component. And that was quite interesting here. Reset the state of a chat component here. For example, like this, right? So for example, like this, hey, I want you to now show is a particular way of doing this. Hey, you're talking to Taylor. Hey, you're talking to Alice. Hey, you're talking to Bob. And how behind the scenes you can now define is a chat service, okay, as a way to look at this data that is coming from that message. Holy moly. Yeah. That makes a lot of sense. That makes a ton of sense. So when we look now at how we can pass data down into different components using context as a way to solve this thing called props drilling. We're not going to talk about that, but the TLDR of that is it becomes quite cumbersome to pass down data to different components. So context is an alternative to do that. We create our context. We also use, which is a JavaScript object from React that doesn't hold any information. It just represents is which context all the components can read or provide data. So we use that context from the component that it needs to, and then we provide that content in an upper level for that. So this is something that you can actually do, whether it's using the provider context from the same structure, or using and providing the context in the same components, or context path through intermediary components. But before you do that, it is important to actually consider passing data. We'll start with props data, or by extracting the GSS and passing it as children to those components, aka you can now pass dynamically that data to those components here. For example, like this. However, when you can use context as a way to now define the small data, because that is a way of how you can now is, for example, make your code much more easy to maintain and avoid re-rendering. Why is that? I'm going to explain is that when is the use case when we can use context. For example, theming, when you just put one minimal value there or one small data there that is going to cause to all of those components to consume that to read it. Okay. We also look at the current account as a way, which is authentication. Okay, that's a good use case for context. Also for routing, because we already use now applications. Yeah, because we already use now applications that okay, because we already now use applications here. Okay. Yeah, because we already now use applications. Yeah, because we already use now applications. For example, like React Router that actually is using a context behind the scenes. When you use that, the browser, the provider or React Router provider, it actually is what's going on. For example, here the router, the React Router, which is now in the version 6 exactly, like so, the main 6.24.21. That's right. So now here is actually using is a context for that, a way to store this minimal amount of information that you want to share across distinct components, which is great as long as they're doing one thing and only one thing. So as you can see here, it not only creates a context here, create browser router is creating the context, and then we're going to provide that like this, router provider here. Pretty much we're actually mimicking is this behavior when we are defining is that. Oh, it is made of Remix. Remix run. But again, this is now for client-side navigation, client-side routing. Exactly. React Router enables client-side routing for that. And how we look at now, you can use that kind of thing. And most of the time, the vast majority of all of those applications, they are not looking that kind of thing. Because most of the time, most of these applications we rely is on picking a router. Oh, but this is in the new version. Exactly. Router component, browser router, hash router, memory router, route, like this, component, wait form, that kind of thing, fetch utility, utilities, and guide. Use actions and all of this, exactly, all of these custom hooks that they provide to you. So, but the TLDR of this is that this particular library, like React Router, which is now made by Remix, the same people, yep, Remix RAM here, which is shout out to all of these people here, totally. Yeah, totally. Totally, totally, totally. Mm-hmm. Yeah, this is the new hop upcoming framework here, like Remix. You also have is Next, like this. It's like holy moly. It's like holy moly, bro. It's like holy moly. Mm-hmm. Mm-hmm. But that's interesting. Okay, I mean, this is just describing is what context allows to do, and also is that when you're using context, meaning that when you use this custom hook from React as a way to read the context, React automatically re-renders all the children that use a particular context, starting from the provider that receive a different value. That's one of the reasons why when you're using, this is one of the caveat of using context, because now it will trigger all of this re-rendering starting from the provider that receive a different value. Oh my god. Perhaps this is what you want. For example, theming. You apply all of the changes to all of the entire render tree. For example, the authentication. You apply all of the necessary changes, or you call all of these React components as a way to update is with this data. But it's interesting that it's not, that React is not, that's quite interesting. That React is not, yeah, that's totally interesting. So React is not capable to update Jesus. So React is not updating those components that are reading the context. In fact, is all children that use a particular context, React automatically re-renders all the children that use a particular context, starting from the provider that receive a different value. What does it mean is that, okay, based on the React docs, use context, the following text Based on the React docs, use content the following text. Does it mean that React will render components that are not using use context, but that are inside of the render tree, but that are inside of the provider subtree? No, React will not re-render components that are not using the context, even if they're inside in the provider subtree. The statement from React docs means that React will only re-render the components that actually consume the context, using use context or context of consumer in class component. When the context value changes, here's a okay, that makes a lot of sense. Okay, exactly. It's more descriptive here. So React automatically re-renders all the children that use a particular context starting from the provider that receive a different value. If any of the in a provider, any of these, the subtree of the subtree from the providers, if any of those nodes are consuming the context, it will call them. So the problem with this is that you then want to know which, oh my god, you then want to know which context or which components are using context. You know, which components are reading that context. Because now you have this indeterministic, and I get it why you have this indeterministic here, which is something that they try to aim, oh my god, which is something that they try to aim is with the reducer in context. Here, with reducer in context. Yes, so with reducer in context. So the caveat with context is that it will, so React will re-render all of the children that are, React will re-render all of the children's okay, so React will re-render all of the children that are React will render all of the children that use a particular context starting from the provider that receives a different value. I think this is a very good way to describe this, you know. So React automatically re-render all the children that use a particular context starting from the provider. Starting from the provider that receive a different value. So the question is, which children are consuming the context? Do we have any visual way to look at that? Do we have a centralized place where you can see which components are consuming the context? That's a valid question. Do we have any way to visualize in code or not what components, to visualize all the components that use a particular context React DevTool, while not a code solution, React DevTool browser extension can help you to visualize the component tree and see which component are using context. So React DevTool and context. Okay, context DevTool. Being able to view and edit the detail from that is something here. React component, non-prompt instance only. But this is the product here. React developer tools, use context, debug US. That's interesting. Okay, the DevTool allow us to do this. Okay, that's great. That's great. React Context DevTool. React Context and use Reducer debugging tool. Start debugging on extension low. So React DevTool allows you to visualize the context. Create a data visualization app with React. How to correctly debug React state update. But that's what happened. Passing data to via context in multiple contexts like this. Scaling up with context and Reducer. Overriding context from a part of a tree. Optimizing re-renders when passing object and functions. Here the context value is a JavaScript object with two properties, one of which is a function. Whenever my app re-renders, for example, on a route update, this will be a different object pointing at a different function. So React will also have to re-render all components deep in the tree that call use context. So whenever my app re-renders, for example, on a route update, this will be a different object pointing to a different function. So React will also have to re-render all components deep in the thread that call the use context. So in a smaller app, this is not a problem. However, there is no need to re-render them if the underlying data, like current user, has not changed. To help React take advantage of the fact, you may wrap the login function with useCallback and wrap the object creation into a memo. This is a performance optimization. So here you're saying, hey, use callback. As a result of this change, even my apps need to re-render the component called in useContext won't need to re-render unless current user has changed. Exactly. If current user changed or login changed, so I want you to now is return this. I want you to re-render this. I want you to now call this with the current user that I get here and the login, which is a callback that I get from this. My component doesn't see the value from my providers. I'm always getting undefined from my context. Also, the default value is different. Doesn't work, no value props. Doesn't work, props should be called value. Optimizations re-render when passing object and functions. Overriding context for a part of the tree. That's what happened. If a component that use a context and that context doesn't change, if any of it is children that use a particular context, if that context doesn't, if the context change, but not it is data in there of that children component or that child component, even though React will re-render that, meaning it will call that component for evaluation. So how can I tell React to not doing that? Well, wrap that context. For example, this. Okay, and you're going to provide only when that data change. Okay, because at the end of the day, with context, what happened is, okay, so React will re-render all of the child components under a specific context, starting by the provider, starting by the provider where value change. Starting from the provider that receive a different value. Starting from the providers here. Starting from the provider here. That's quite interesting, man. Starting from the provider here. Starting from the provider here. Okay. Starting by the provider. Starting from the provider here. Yep, starting from the provider here. Starting from the provider whose value change. Starting from the provider that receive a different value. So for example here, if you're passing this, okay, here the context value, here the context value is a JavaScript object with two properties, one of which is a function, one of which is a function. Whenever my app re-renders, for example, on a route update, this will be a different object. Yeah, when my route updates, this will be a different object pointing to a different function. Okay, this will be a different object pointing to a different function when you route updates. Whenever my app re-render, for example, on a route update, it'll be a different this will be a different object. Set current user, it will be a different object pointing a different function. It will be it will be pointing a different object pointing to a different object because it's evaluating this. It's creating is this. So React will also have to re-render because you are here in JavaScript. So anytime my app re-render, for example, on a route update, so the current user, the object is a different. This will be a different object and a different function here when it render, when it call this. So this will be a different object pointing to a different function. So React will also have to re-render all components down in the tree that call useContext. So in a smaller app, this is not a problem. But however, there is no need to re-render then if the underlying data like current user has not changed. So if the current underlying data has not changed, but it's because anytime it re-render, this will be a different object, the current user. Based on the following text from React docs, anytime React re-rendering is creating a different function, is running a function with different objects and function reference in memory. And reconciliation process work. Let me break this down a bit of it. Oh my god. So anytime React re-render, is running a function with different objects and functions referencing memory. So it means that it's called, of course, because this is JavaScript, it's, now holy moly. It has a different referencing memory because after all, it creates a new function execution context because it creating is a new execution context where it say, hey, this current user and this set user is part of this use state, okay, which is a closure, but this function definition is different. So JavaScript is not only looking at all of your line, but part of the thread of execution line by line, but it's reserving space in memory. So when you evaluate this function, it creates not only its own function execution context with its own thread of execution, which is evaluating its line after the another, and also the memory. So when you run this, it say, hey, this use state, okay, which is a closure that is behind the scene that is working, but this function login now is, this is the first time that I'm running this function, or I'm running this function, and then I'm going to return this. So current user and logins are different when you rerun this. So when React re-render these components, all of these references are different. Mother. Because this is part of the JavaScript. It say, hey, I run this function, that's it. So re-rendering is a new reference. When a component re-rendering, therefore it run that function, it run a function body again. This means that any objects or functions defined inside of the component will be recreated, because after all, anytime you are creating a function or you're running a function, a React component, it is creating a new execution context, which of course resulting in the creation of the new referencing memory. God damn it. Implication for context. In the example you provide, the context value is an object containing a function. So performance consideration. This behavior can lead to unnecessary re-rendering in the child component. Why is that? Because React will re-render. Okay, let's say you're okay. Oh my God, they have different reference, and if you use a context provider here and you pass that data, you are now, anytime it runs this from the provider, you're actually passing is a new reference, meaning this is a different object and a different function to the value. And what's happening is that context, the way it was defined is, let me now re-rendering this context provider, or React will re-render children. React will re-render all of these children's. React will re-render all of these children that use a specific provider or that use a specific context, starting from the provider. Starting from the provider, that value that receive a different value. Starting from the provider that receive a different value. And the problem is that because it's receiving, when it render this, when it's evaluating this function, of course, this is a different reference, and this is a different reference from the current user and login here. Therefore, the value is different. Therefore, it will now re-render or call all of the components whose states are different. It's going to render all of the child components. It's going to render all of the children that use that context, starting from the provider that value change. You are now performing is a cascade effect here for that. Jesus. This is when you need to understand is JavaScript. This is when you need to understand JavaScript. So to prevent this, you'll need to find a way to wrap this thing in a memo. Use callbacks are useful for a wrap. Like you catch a function oh my freaking God! It allows you to catch a function's definition between re-renderings. Holy French toast! God damn. Oh my God. Oh my. Ooh, nigga. Ooh. All right. That's why you need to understand JavaScript, mother. Because use callbacks lets you catch a function definition between re-rendering. Hey, this is the same reference, bro. This is the same reference, bro, and useMemo. So here what you can do is to say, let me wrap this login into a use callback as a way to catch this between renders, okay? And only when that changes, hey, I want you to run this, and catch is allow you to, in memo is allow you to catch the result of a calculation between re-renderings. In this case is use memo, and you're gonna return is this object. So I want you to catch is the current user and the login, and only update them as long as they change here. So when they change, all right, do this for me. All right. So avoid during re-rendering, during calling these components, I want you to catch a version of this, okay? And if those change, all right. Logging response and this kind of thing. And now here, you are now avoiding to pass a different reference anytime it re-renders. Therefore, you will now have the ability to write a much more performance React application using context. Holy F. Holy F, bro. Okay. All right. So I know now this, okay. I know this thing is a content of re-rendering, which is calling a JavaScript function, and when it re-render that, because it create a new brand execution context, those computations there, those expressions that it finds that they are new reference. And use callback allows you to catch is the function reference between rendering. Very specific, very specific. And by catches, closure that. Closure that. And the other is the use memo, would say, hey, I'm going to now save you recomputation. I'm going to catch this computation between re-render, of course. I will argue that those use are closure behind the scenes. Those use or those hooks They're just collections. Holy sh! Okay. Now I understand what useMemo is as useCallback is. I truly understand that. Because they store, the useCallbacks allow you to store is the reference of a functions between rendering, aka you can catch this. And then the second argument is an array of dependency. Hey, when you want to now let React to re-render this, okay? Or computate this, and useMemo allow you to now is catch computations. So with this, instead of actually recalculating this, in other words, instead of actually entering into these functions and having to render or having to evaluate these expressions over and over and over, even though they don't change their value, but when you evaluate like this, you are, or when JavaScript evaluate this, it creates a new reference for that. Therefore, it's a new object, it's a new function reference, and that's what happened here. So by using this now useMemo here, you can now do this. Holy F, bro. Holy F, bro. Oh my God. Okay. Okay. You may have forgotten to wrap your component with some context provided. You might have to put in a different part of the tree. You can check. Check whether the hierarchy is right using the React Dev tool. Okay. Use callback, use context, use debug value. Let you add a label to a custom hook. Use the defer value. Let you defer updating a part of the UI. After, I will argue that all of this use is just, they are context. They are closure here. Use ID, use imperative, use memo, use layout effect as a way that exactly. It's a version of use effect that fire before the browser repaints the screen. Okay. Use reducer, use ref, use state, use sync external store, and use transition, followed by the component here. The view idle component, fragment profiler, Let's measure your rendering performance of a React 3 programmatically. Measuring rendering performance programmatically. Interesting. So let's now keep looking at the, oh my god. Of course, because React is now re-rendering. It means that it's calling that function, and after all, that function. So, because when React mentions re-rendering, it means that it's calling that React component. And a component, and a React component, is just a JavaScript function. It means it's creating a new brand execution context from that, which means that it is on thread of execution followed by its local memory. God damn it. Holy moly, bro. Honey. All right, you need to pay for your mentors. That's all I'm gonna say. You definitely need to pay for your mentors. That's all. That's it. That's it. That's it. You need to pay for your mentors. Yep. Yeah, it is. Oh my god. So, now that you truly understand context, as well as the useMemo and useCallback, which allow you to catch a function reference between re-rendering, and useMemo allow you to catch is a computation between render. They are useful if you're going to provide now is a new value to the context. So it doesn't actually need to recalculate that anytime their value, the context value change. Oh my god. Okay, and this is something useful. This is something useful when you are creating a theme. When you're creating a theme, yes. Yes. The question is are they using, for example, in GitHub in the React, it's like React router. In React router, the code, which is open source, I love it. Okay, is this code docs here? What if I want to in the package here? React router, exactly React router. Here, the lib, okay, is inside of this. I get it. Context, where of course you have a huge giant context, index route object, non-index route objects, and then you get is this is a type, and they're using this interface as a way to be as a way to now let the user consume this index route object, non-index route object. Okay, export type route object like so. Export type data route objects as it is. Export interface route match pattern keys and extend string as a way to extend from this agnostic route pattern key and route object type. Pattern key extend from the string equals string. Oh, okay. Route object type extend from route object type equals counter.tsx accident counter. Exactly, counter tsx accident counter. So for example here, when I define these things like this, query client provider, not at all. Extend the object So here's now is the context from this. All right, React create context. The navigator, the interface, and then you got all of this. Export interface route context object like this. React.create context, and if that route and this is just the context, which is the data. followed by the component that actually allowed you to do this. And that are our context provider. And of course they're using useMemo for this, because it say, hey, as a way to update this data from the context provider, we're going to now catch that between renders, and only when specific array of dependency change. Jesus freaking Christ. Followed by the state here. And they are receiving here. What in the F? That's quite interesting. But again, context is not bad. Okay, if you want to create, if you want to keep, if you want to use a small piece of information. If you want to use a small piece of information, yes. God damn. Holy moly, bro. Holy moly, bro. Holy moly, bro. Holy moly, bro. That makes a lot of sense. This is the lib here. Is using rollup for that? Yes. Yes, transformer is a way for running the tests, followed by the hooks, and they have the here. Use href, and inside of that, they must be exactly use the context here. All right. And export the using router here. Is another context. You're using is another context. Followed by the context here. And it is interesting because they are not using the, all of these components are just reading the context. All of these components are reading context. All of these components are just reading context. And when we look at now scaling up with reducer and context, so reducer lets you consolidate component state update logics. Exactly. To consolidate is the state update logic, where context lets you pass information down to other components. You can combine reducer and context together to manage state of a complex screen. That's quite interesting. That's quite interesting. So in this example, from the introduction to reducer, the state is managed by a reducer. But this is as a way to manage state of a complex screen. Complex screens like drag and drop API, for example. you know, and that's why we have here drag and drop API for this. Mm-hmm. 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 Interesting. Mm-hmm. This is something very, very interesting. Mm-hmm. Holy moly, bro. Okay, okay. Mm-mm. Mm-hmm. 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 Okay. Mm-hmm. Mm-hmm. Jesus. So combining a reducer with a context. The reducer function contains all the state update logic and it is declared at the bottom of this file completely. The handler, the task, is like the reducer is defining at the bottom of this task. So the state is managed by a reducer. The reducer function contains all the state update logic and is declared at the bottom of this file. So far so good. A reducer help keeps the event handler short and concise. Exactly. So it make you to keep all of your event handlers short and concise. However, as your app grows, you might run into another difficulty. Currently, the task take and the dispatch function are only available in the top level task app. So this state and the dispatch function is only available here. But for some reason, you want to make that available in other places. To let other components read the list of tasks and change it, you will have to explicitly pass down the current state and the event handler that changed its props. For example, like this, task and the on-chain task and on delete task. Furthermore is the task and on-chain task and on delete task. In a small example like this works well, but if you have 10 or 100 of components in the middle, passing down all the states and functions can be quite frustrating. This is why there's an alternative to passing them through props. You might want to put both of the task state and the dispatch function into context. This way, any component below task app in the tree can read the task and dispatch action without the repeated prop drilling. Exactly, because with reducer you now consist, so you make your event handlers short and concise. Okay, short and concise. But if you want to now share that state in other components, you will have now is to pass down the state as it is event handlers onto the component. So if you have now hundreds of thousands of components, but it's funny because if you have 10 or hundreds of components in the middle, which is, it seems that for Facebook it's not that weird to find that kind of data here. Oh my god. So here's how you can combine a reducer with a context. Create a context, put the state and dispatch into the context, and then use the content anywhere. So if I take a look now at subscribely, this one, but from the GitHub, that's right, from the GitHub. here. And in the app and in the component here, we only have this action. And it's inside of your component that it defines this JavaScript logic as a way to handle that category here. Followed by the search, where it's gonna lift state up, use a reducer here, because anytime you have to handle this kind of thing, it's a document query selector search input inner text and trim, which is quite interesting. Content editable. Evaluate this. Okay. And then you're going to store this memory persistently. Oh, because it. Oh, because you're receiving that. Oh, okay, you're receiving this as a props. sign. Speed inside. Okay. nothing started to make sense when it comes to client side and server side rendering. Mm-hmm. This is interesting here. That's very, very interesting, bro. Very, very interesting. As a way to give you a sense of what you can do here for now. Mm-hmm. 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 you create your two contexts here, your task and your dispatch context, and you put the state and the dispatch into the context like this. You say, hey, this is the text context provider, the value, followed by the dispatcher. Yeah, you create two contexts here. You create two contexts here. But when this is evaluated, when JavaScript re-renders, when React re-renders this component, aka JavaScript evaluate this function, meaning it calls that, it creates a new branch execution context. Each one of them will be a new reference for that. Which is, hey, this is a new reference. This is a new reference. This is a new object, and this is a new function here. When you're doing this, which means that React will re-render all the childs that, so React will re-render all the childs that can have access to this context, starting from the providers that value change. So to prevent unnecessary re-renderings, especially when you're passing things like this, you can now wrap all of your functions here into a callback and then determine when to run those functions. Because anytime React will re-render this, it will now re-render all of those components who have access to the context, starting from the provider, that value change. But you don't want to rerun these functions here. Especially the dispatch here, which after all they are just functions. Okay. And use a context anywhere in the tree. So meaning you can use a context for that. Use a context, exactly. You can use the task context. You're gonna get the date, the state, followed by the dispatch, where you're gonna update the state update, and be able to dispatch and update that from any place here. The task app component does not pass any event handlers down the task list, and does not pass any event handlers to the task component. So the task as component does not pass any event handler down, and the task list does not pass any event handler to the task component either. Each component reads the context that it needs to. So for example, here in the in the add context, it reads the context that it needs to. Add a task. Here we're gonna dispatch this event. And in the task list, I want to read this event. This state still live in the top level task app component managed with a use reducer, but it is task and dispatch are now available to every component below in the tree by importing and using this context. Moving all wiring into a single file. You don't have to do this, but you could further declutter the component by moving both reducer and context into a single file, as a way to declutter this a little bit, but meaning reducer and context into a single file. So currently you have this, and it's in your task context. What you're gonna have is all of that. It's in your task reducer here, you're going to move all of these task reducer followed by the initial state into its own context here, inside of the task context. What you're going to receive is the children, not only exactly what you're going to receive is the children and the task provider. You're going to render all of this and doing this. So here you're now abstract this component that owns the state that can be shared across multiple components. So when the value of the provider change, it will also all of those children that use the context will re-render. So React. So in this case, because now when we used our reducer here inside of this function, this React component, as a way to not only define is the state in our context, but also is to provide is the reducers here, followed by the initial, followed by the initial task, or followed by the initial task, but the initial state here, and then return is the provider, and then return is the task provider, which is return the state and the dispatch. Okay. And then when you want to use that followed by the children as a way, hey, the children that I'm receiving here, I'm going to pass down and I want to render here. So any React will re-render those child components that read the content, that specific context. So React. So React will re-render the children that. React will re-render the children whose React will re-render the children's React will re-render the children's components, or React will re-render all of its children's that read that specific context, starting from the provider that value change. So this is not a good thing if you, for example, have a lot of if you, for example, when that provider's value change, and when the provider has a lot of these different functions reference or state reference, it will call that, and if you pass down that, it will also re-render all of those components who read this specific context, starting from the provider, that value change. So this is something that you don't want to. Definitely you don't want to. So for this case, might be good enough. For this case might be good enough. For this case might be good enough. Because after all, here is just evaluating is only the task and the dispatch. Okay? So you can also export functions that use a context from task context, like this. You can also export functions that use the context from task context, or this one. So when a component needs to read the context, it can do it through this function. Use task and use task dispatch. And behind the scenes is using a context, which is wrapper into a state or into a reducer that makes the state update logic concise and short. This doesn't change the behavior in any way, but it lets you later split this context further or add some logic to this function. Now Exactly. This doesn't change the behavior in any way, but it lets you split this context further and add some logic to these functions. Now all the context and reducer wiring is in the task context.js. This keeps you the components clean and uncluttered, focus on what they display rather than where they get the data. So here you remove, okay, you make use of the task or this particular state, aka disclosure, okay? And in the add task, use task dispatch to make it sense for that. You can think of task provider as part of the screen that knows how to deal with tasks. Use tasks as a way to read them and use task dispatch as a way to update them from any component belonging in the tree. Functions like useTask and useTask dispatch are called custom hooks. Exactly. Which is reusing logic with custom hooks. This let you use other hooks like use context inside it. As your app grows, you may have many context reducer pairs like this. This is a powerful way to scale your app and lift state up without too much work whenever you want to access the data deep in the tree. A recap. You can combine reducer with context to let you any component read and update state above it. To provide state and the dispatch function to the components below, create two contexts for state and dispatch function. Provide both context from the component that use a reducer. Use either context from component that needs to read them. You can further declutter the component by moving all the wiring out into one line. This is something quite interesting. This is a powerful way to scale your app and lift state up without too much work whenever you want to access the data deep in the tree. So if I want to access the data here, okay, this might be good. Here you're not using context. Here you're not using context at all, but you're using this reducer. This is quite interesting here. This is quite interesting here. So that'll be all for this video. Take care. Bye bye.